Alright, so let's just do the question number 46. So for the 46, we are supposed to get, supposed to find out which one of these is stronger acid and which one of these are weak acid. And the reaction formula is given in each one of those, right? So H2O and H2O becoming OH minus and H3O plus, that's, we already did this one, but I'm gonna repeat it. Oh, do I need to? I'm not really sure. Ethanol is this guy reacting with water to produce something O minus and H3O plus, and then phenol, which is this one, plus H2O producing something O minus and then H3O plus, and pKa is given. So there is two different ways of doing this. One is not to use Excel to find out, and then the other one is use Excel to find it out. So let's just do that one. So we already, let me just try to minimize this so that I can actually have the extra space here. So I already wrote down this one right here, right? So for this, let's just try to find out what the pKa is, right? So what is pKa? pKa is equal to minus log of Ka, right? And then Ka right here is equal to 10 to the power of negative pKa, right? So that's pretty much, that's all I need to know. And then what is Ka here? Ka is actually product over reactant. So if I write it in this form right here, the generic form of the acid dissociation constant, that's pretty much what I have, right? Then what does this mean, this Ka mean? If I have the large number right here, large number for H plus and A minus, Ka is going to be large, right? And HA being small, Ka is going to be large, right? And if I have H plus and A minus being small and then HA being large, then Ka is going to be small, right? So if the Ka is large, you are producing lots of H plus. That means that if the Ka is large, acid is strong because it produces more H plus. Okay, so let's do that one. So let's just modify this pKa to be the Ka right here. So I'm gonna write Ka here. Ka is equal to, I'm gonna use this formula right here, 10 to the power of that guy, right? So you got that. Oops, minus, so minus, right? And then I do the same stuff for these guys. So that one right there is minus log, minus 10 to the power of minus H3. The same stuff, 10 to the power of minus H4, right? So I got these guys. So remember that Ka large means that you produce lots of H plus, right? Because you want the denominator to, numerator to be big and denominator to be small, right? So Ka large means that you are producing lots of H plus. Which one of these guys is the biggest? This one right here have 10 0 in front of this one, and this one right here have 16 0 in front of this guy, and this one right here have 14 0 in front of this guy. Which one is the largest Ka value? It's this one, right? So that one is large Ka, and this one is the smallest K, right? Which means that this one is the strongest, and then this one is the weakest, and then this one is medium. By all means, it's comparison, right? Alright, so we got all of that. Now let's do the one of these guys. So I'm gonna repeat the same stuff. So I'm gonna copy this and then I'm gonna paste it right here. So we start out with one more of this. Oh, let me just write. The reason why that I wanna keep it in terms of the 0.01 was I remember something. So the second part of the problem right here, the calculate the pH of 0.01 molar solution. 0.01 mole solution. So I'm gonna put 0.01 here. I'm gonna put this one to be 0.01 too. Right? And then the change right here. Yeah, you already guessed that I don't really need to do any of these guys, right? Because this is pure liquid, right? Both H2 and H2O is pure liquid. I don't really have to do this, but I'm just doing it for now, just because I can actually do this. Okay, so that one right there is going to be minus x, and then this one right here is equal to this plus this, right? And then let's just do the Q here. Q again is a product of a reactant, but these are the pure liquid, right? These are pure liquid. I'm gonna emphasize this. So it doesn't really show up in the equilibrium constant or Q. So that one right there looks like this. I'm just putting right like this, right? Okay, so let's just do the Ka to be 1e negative 14, right? Alright, so let's just do the solver. And I want to have Q is this one, to have a value of 1e negative 14 by changing that, right? Now let's just check the options. Yep, it's negative 1e negative 20, 1e negative 20. Each one of these is 1e negative 20. Okay, so this should work. Make sure that this thing is unchecked. Click that. Voila, you get e to the negative 7, the 10 to the power of negative 7 for each one of these guys. So H2O right here, the pH is 7, right? Minus log of G9, which is 10 to the negative 7 here. So okay, all of these things are good. So the pH for this solution is 7. Okay, let's do this one right here. So I'm gonna copy this and paste that. I think it was this one. Okay, good. Alright, so for this one right here, this doesn't have to be anything, yeah, but this one right here is that, right? Then that's this and that's this. And that one right here is going to be the, this particular things. I'm not going to change the colors, okay? You guys do it if you want to. And the Q value right here, let me just try to change this one to the normal small value, smaller than these guys, right? And then the Ka value, not K value, Q value is the product of a reactant, right? So the product is that and that, divided by the reactant, which is that one. And the Ka value is 15, so it's equal to this guy. So let's just try to solve the situation here. I have to warn you that before I do anything, this is probably the hardest acid-base problems. So I'm gonna do the same stuff. I'm gonna make Q, that's Q, then have a value of 1.59 e to the negative 1.5 e to the negative 16. Yeah, I'm sorry, I don't know how I actually put this 1.59, 15.9, it's pK. It's supposed to put Ka value, right? Not pK. So 1.26 times 10 to the negative 16 goes in here by changing x here. By changing x, right? And then I'm just gonna do this one. When you find this, you have H3O value right here, which is going to be really tiny. Tinier than actually what it should. Can you guess the reason why that's the case? If you can actually guess this one, you're a genius, by the way. What happens is the solution right here is H2O, right? So H2O actually produce 10 to the negative 7 H plus and OH minus. So what this initial value is supposed to be, it's actually 1E negative 7, right? And that's pretty much what you really need to figure it out. So initial value is this, the change value is these guys. So I'm gonna reset everything and see what happens. This is already good enough answer for most of the chemistry class, but I'm gonna redo everything, just solve it. Then you got pretty much the answers here, which is 6.99. Let me just try to get to this one right here. Did I actually do that one correctly? And then option. Okay, that's good. Sometimes that you may not actually able to find the solution. That's perfectly fine. It's pretty much how the things goes. So when you just try to find it. Yeah, I guess that if you actually start out with 0.001, then you're gonna find the solutions. So which is this one right here. So you have that, and then you have that for this concentration, and then the initial concentration didn't even change that much. So that's how you do the problem correctly for this one right here. I can guarantee you that I'm not going to ask you anything like this. Not on this one, okay? That's difficult. But I did actually show you one, okay? When you actually try to take the quantitative chemical analysis, yeah, you already know how to solve the problem. Alright, so once we are done with that one, let's try to do this one right here. So I'm going to put this one in here. And then I'm going to put this one here. Okay, so I have 0.1, 0.001 here, and then this one right here, I'm going to set it back to 0.001 right here. I don't have to do anything here. I don't have to do anything there. And then the Q right here, was I actually doing that? I hope I was actually doing this one. Well, doesn't matter. So you just need to have that one to be the reactant. So product over reactant is this one, right? And then the, that is 1e negative 10, right? So let's do the solver again. Now I'm actually thinking about actually changing this one to 0, but if you wanna keep these things to be 1e to the negative 7, that's fine, but I'm gonna change this one to 0, and then let's just redo the same stuff later. So I am going to change Q, right? Q to have the value of 1e negative 10 by changing x, right? Make sure that this thing is 1e to the 20. Then borrow, you find the solution, which is that. Oh, why am I actually having this? Just pushed it. So you got this number right here. So that's a pH. So pH of, what was this one again? I forgot. Go back to the video before I forgot about that one. So that's pretty much what I have for this one. So this one has the high pH value, this one has a low pH value, and this one has a medium pH value. But that's pretty much how you calculate the pH using Excel. Now, let's just, for the sake of argument, I'm just going to do the 10 to the negative 7, right? And then I'm just going to do these things with 0.001 again, right? And then I do these things to be the 10 to the negative 10, 1e negative 10, right? And then product over reactant, that's fine. Solver found the solution. You see that that one is slightly different from this one. This is more accurate, but they're close enough, right? So putting this 1e to the 7 at the beginning is not gonna hurt you that much. That's not really the source of the errors. Okay, so you can actually put 0 here, or the 10 to the negative 7, but that's how I solve the problem by using Excel.